Hello everyone! Today, we are going to tackle a fundamental skill in chemistry, how to calculate ratios from a gas chromatography, or GC, analysis. It might sound complicated, but the process is actually very straightforward once you understand the steps. We will break it down simply, so you can confidently analyze your own data and understand what it means. First, why do we even calculate ratios? We do this to determine the composition of a mixture. We might want to know how much product we made compared to a starting material, or the ratio of two isomers in our sample. The GC instrument separates the compounds, and its output is a graph called a chromatogram. On this graph, each sharp spike, or peak, represents a different compound that was in your mixture. Your first step is to simply identify your peaks of interest. You need to know which peak is compound A and which is compound B, which is usually done by running known standards beforehand. The next, and most crucial step, is integration. The GC software automatically measures the area under each peak. This peak area is directly proportional to the amount of that specific compound. It is very important to use the peak area, not the peak height, because area provides a much more accurate and reliable measurement of the compound's quantity. Once you have the integrated areas for your peaks, let's call them area A and area B, the calculation is easy. A very common and useful method is to calculate the area percentage for each compound. To do this, you first sum the areas of all the peaks you are interested in to get a total area. For example, total area equals area A plus area B. Then, to find the percentage of compound A, you use the formula, area A divided by total area, and then multiply that result by 100. You do the exact same thing for compound B, area B divided by total area, multiplied by 100. Let's imagine your analysis gives you two peaks. Peak A has an area of 9,000 units, and peak B has an area of 3,000 units. The total area is 9,000 plus 3,000, which equals 12,000. The percentage of A would be 9,000 divided by 12,000 times 100, which gives us 75%. The percentage of B would be 3,000 divided by 12,000 times 100, which is 25%. So, you can report that your mixture is 75% A and 25% B, or that the ratio of A to B is 3 to 1. It's really that simple for most routine analyses. And that's the core of how you calculate ratios in gas chromatography. I hope this breakdown was clear and helpful for your work in the lab. Thank you so much for watching. If you found this video useful, please give it a thumbs up and consider subscribing to the channel. Your support is greatly appreciated and helps me continue to make more educational content. See you in the next video.